Hello everyone, my name is Rahul and today we will be solving a subset problem. That is, we have been given an array and we have to find all the possible subset of the array. This problem is very important because it has been asked in many companies interviews and it is a basic building block for many higher hard algorithms and problems. So today we will be discussing two approaches to find all the possible subset. First one is recursive approach, which is easy and more intuitive, and the second one is the iterative approach. Now moving towards the first approach, which is recursive. Now let's discuss first. Now suppose if we have been given these 5 elements, to find all the subset, what we can do is we go to the first element and say if we want to take one or not, and if we want to take one or if we do not want to take one or not. In both the cases we will be moved toward the second index, and towards the second index we again ask a question if we want to take it or not, and move to the third, and same for the others. As you can see, at each index we will be making two decisions of taking or not, that will multiply over the again if we move towards the right of the array. So these now at first we have two options. Now at the second we will be having total of the 4 options. Like we have not taken 0, we have not taken 1. The second option will be we have taken 1 but we have not taken 2, and the third option we have not taken 1 but we have taken 2, and the fourth option would be like we have taken both of them. So as you can see, if we are going towards more and more, we will be having more options. So basically, if in this case if we have like 3 elements, total number of possible ways will be 2 into 2 into 2, which is 2 to the power 3. And if we have n elements, then we will be having 2 to the power m of n number of subsets. As you can see in this example, we have 1, 2, 3 as a element. There are total of 3 elements, so we can see there are the 8 subsets. So using this intuitive approach, let's make a recursive function here. So let's make a void function. We will be having a index I, and we are having our nums array, which is as reference because we don't know. Let's say now we want an array to store all the possible subsets, so let's make it here, which is, let's say, ans. This is reference because we do not want it to change after each recursive call, so we will be making it reference, and a vector which is temp, in which we will be appending all the elements. We do not want it to reference because we want it to change on each call. Now let's first make here the answer and temp vector. Now the base case would be, as you can see, we will be going to all the elements. Like first we will be going 1, 2, 3, then again till the end, and after that we do not have any element, so we will be stopping there, as the indexing starts from 0. So we will be going to the n minus 1. So if we encounter n, then that means we have to stop there because we do not have nth element in the array. So if I equals to nums.side, which is the n, then at that point we will be appending our temporary vector, and we will be returning because we do not want to go further. Now here comes the good part. We have two options. First one is we do not want to take. So if we do not want to take, we will be simply calling going to the next element without appending the element into the temp. And yeah, and second option, we want to take element. In that case, we will be appending the element to the temp vector, and then we will be calling the next I plus 1 index. Yeah, okay. So, and if I equal to numpsci, then it will automatically be stopped. Now I think this should work. And now let's call the function I is 0 because we will be starting from 0. Nums we have, ones we have, and temp we have. Yeah, now we will be returning our answer vector. Yeah, let's see if it works. Okay, so it's saying, okay, sorry. So let's submit it. Yeah, so as you can see, it's submitting. One more important thing you have to note, as you can see, the total number of subsets would be 2 to the power n. Then n should not be that large. Like if n should cannot be like larger than 20 basically, but in this case as n is 10, because 2 to the power 20 would be around 10 to the power 8 operations, and if suppose n is equal to 40, then in that case 2 to the power 40 would be around 10 to the power 12, which we cannot process easily. Like it would take a lot of time. So in the subset questions like this, the value of n would be around not greater than the 20. There will be some question which will be subset based and having n less than 40. These problems will be using different algo, which is known as meet in the middle algorithm. So technique, algorithm, whatever you say. So in these cases, we can use this for n equal to 40 by making a law, by making a technique like we divide the array into 2, n by 2, n by 2, and we will be using both of them independently. This is a problem which we will encounter later. Now let's move to the iterative solution. So for the iterative solution, at first the one thing you have seen is the total number of subset would be 2 to the power n. Okay, now now as you can see, like let's make a binary representation of all the elements from 2 to the power 3, like 0 0 1 0 0 1 0 6 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Now as you can see, if we have 1 2 3 as the elements in the array, then you can see, like from let's start from the rightmost of the bit. Like if let's say if this implies a 0 index, first index and the second index, then if it is a 0, we say that we do not want it in the subset. So if it's 0, we do not want 1, it's 0, we do not want 2, and it's 0, we do not want 3. So in this case, this will be having a empty subset. We say this is having an empty subset. Now this is 1, we want 1, so we will be having 1, and both of them are 0, so we don't want 2 and 3. In this case we want 2, in this case we want 1 and 2. So we want 1 and 2. In this case we want 3. In this case we want 1 and 3. In this case we want 2 and 3, and in this case we want all of them. Now you can see this is giving us all the possible subset. So using this technique we will be iteratively having all the possible subset. Okay, so let's make it. So now how do I will check that we want, like, this is 1? How do I check if this is 1, like which one of them I want? So one operation, like you can convert, like if this is 0, 1, 2, 3, 4, 5, 6 and 7. One way is you can convert these int values to the binary string, and if it's 1, like over all the indexes, you can do that. Other way is, if like these array have indexes 1, 2 and 3, 0, 1, 2, we can do what, like if we say 2 to the power of 0 is like 1 in 1, and in binary representation it would be again 1, like 0, 0, 1. So if we will be iterating all of them, like this one, and if we encounter this, then 0, 0, 1 would be 1. If we encounter this, because it also has 1, so in that case it would be 1. Like if we do not want 1, like if this is the 1, then we can say that this is going to be 0, and if it's 0 we do not want it. If it's 1 or greater than 1, we want it. So we will be using this approach, like if like for this one it would be like 2 to the power 2, and it would be 1, 0, 0, and all the like values of them. If we have here 1, we want it, otherwise we do not want it if it's 0. Yeah, so we will be using this approach. I mean, you can take a look and then you can try to understand if you do not get the point here. So for these, first of all we have to go to 0 till the 2 to the power n. For that we will, let's say we want from 0, then we will want to 2 to the power of n. For that I am using this operation. You can also use like power of 2 to the power n. This will also work. Now let's make a vector here, because we want it to append in the answer vector. Now we will be iterating all the elements to check if they should be included or not. Now for that, what we will be doing, like if like I have explained like this, then I will say I and again 2 to the power of j, and if it's 1, or we can say it's 1 was not 0, then we will be appending the element, like we will be appending the jth element to the temp, and at the end of the loop we will be appending the temp here, and simply we will be returning it. Let's comment this all. Okay, so and it's not defined. Int and nums dot size. Yeah. Okay, so it's working. As you can see, we have shown both the iterative and the recursive approach, and we will be using the iterative or recursive approach. Both you can use in the further questions, the hard ones. Yeah.